Now let's try it, that same problem, but let's start with the distributive property, right? Now we have the entire thing, it's the complement of the entire thing, and since we're using the single quote, we need to put it all in parentheses. So we have, in fact, I'm just going to write that just to make sure that I've got that correct. Y and the complement of x, and then it's the complement of that whole thing. And this really, all I did was change the complement operator, right? So nothing new there. I didn't really change the problem. I just used single quotes instead of the bar. Okay, so now let's go ahead and get started with the distributive problem, or the distributive property, or law. So we're going to distribute that x times into each of those terms. So it becomes x times y plus x times the complement of x. And there we still have the complement of that whole thing. And so that's the distributive. And it's that version right down here. Okay, now we have the x times the complement of x. And so when we have x times the complement of x, that's 0, and that's the complement law. So we have xy plus 0, right, which is the complement law. And now we have the complement of an addition operation, so we can use demorgans, and that becomes, and now we need to be careful when we do demorgans, it's the complement of the first term, and notice that first term is a multiplication, so we need to make sure we do the complement of the whole thing. So that's going to be xy and the complement of the whole term, and now it's that times the complement of 0. So that's 0 complement. All right, so it changes from an addition to a multiplication, and we do complements on both of them. And again, that's De Morgan's. Okay, now we can do the complement of 0, which is 1. And that's just the complement law. And notice we use two very different complement laws, but they're both in the same category, both listed as complement laws. And now we have a term times 1, and this is the identity law. When we multiply anything times 1, it remains that thing. So we end up with x, y, the complement of x times y. And so that is just simply the identity law. And now we can do De Morgan again, right? If we want, right? If we want to do De Morgan, then it's the complement of x or the complement of y. And notice we're back to the same thing. We have either this or this, whichever suits your purpose, whatever you're doing. And if we take that and we go look how we did it when we started with De Morgan's law, notice that we end up with exactly the same thing. So, which makes sense. If you apply the laws, it doesn't ever change the problem, right? You should end up with the same result no matter which order you apply the laws. And sure enough, that's what happened.